So I will talk about openEO, which is basically cloud-native geoprocessing. So not about a file format here, but about an API and process descriptions, basically. I'm working for the University of Münster and with another couple of companies in the European Union. We're developing this since 2017. So why did we do openEO? Well, basically you have a number of programming languages and clients like R and Python that all want to do EO processing. And there are a number of cloud providers that do that, like Google Earth Engine and Sentinel Hub and others. But they all have their own API. So what we have right now is this mixture of things, and that doesn't really work out for people because they need to learn a lot. So we defined, or our vision was to have an API that sits in between and translates all the requests and focus on what the user needs and what he wants to achieve, and not how to do it, right? Not to learn a specific API for each of the providers wherever the data set is that he needs. And of course, I'm working for a university, so it's always good to have reproducible results so that you can check whether what you get out from your cloud environment is actually what is the right result, and it should also be, in this case, interoperable, of course. So what is it? Well, it is a language basically for geospatial processing, so an API and a set of processes that you can run, basically, an extensible set of processes. It is cloud-based, it is open source and community-driven. So anyone can contribute to that, can propose extensions, can propose new processes, and it's all centered around data cubes so that the data access is really easy, and you don't need to fiddle around with like files or any specifics here. What is it not? Well, it's not specifically another cloud provider. I mean, there are implementations out there, of course, for example, openEO platform, but it's not like a single one, right? Everyone can implement this API and processes on their existing stack of tools that they have. It's also not another geoprocessing software, of course, and it's not using the traditional GS style where you have files and tiles and where you need to figure out how to combine them. It also handles time natively. So the API is covering a couple of things like discovery for EO data for the processes. It also covers authentication via OpenID Connect. You can, with the predefined processes that we have, also define new, more complex user-defined processes and store them and reuse them again in another user-defined process. You can upload and download your files, of course. You can process the data that you've selected either synchronously or as larger batch jobs. And you can do on-demand processing via web service. So if you like have a web map and a workflow that you want to run, you can do that on demand so that you can see or the data is just computed on the fly, basically. We have a set of predefined processes, I think roughly 150 at the moment, mostly centered around EO processing, but it's extensible. So it is basically possible to also go to other domains here and extend it. You can define user-defined processes based on the predefined processes and other user-defined processes. And then there is a concept of user-defined functions right now implemented in Python and R. That means you can upload custom code that you have previously written in Python and R and make it part of your processing chain. We have clients implemented in JavaScript and TypeScript, which power the web editor as well. So we have a browser-based client. We have Python and R as very common programming languages in the EO world. Both integrate into Jupyter as well, so you can see nice UI widgets coming out of them if you run the clients, and also works well with RStudio and R Markdown. We have a Vue.js client, but that's unmaintained right now, but we'll pick that up again in the future. So this is basically then an accept of the code that you could run. So it's really just you do all the processing on the like write all the code on the client side in the language that you know, similar to how you have done it before. It's really well integrated here in Python, for example, and then it's just translated into a process that is transmitted to the backend and can be run there. The same looks very similar in R, so it's very, very easy to get used to that, I think. And if you don't want to program, you can also use the web tool, the web editor here, which is a nice UI component which covers everything, including map, showing things on the map, etc. There are a couple of backend implementations which are all open source, which you can reuse and set up. For example, for GeoPySpark, GeoTrellis, we have multiple instances running on OpenDataCube, which proxy that interface, or GraphJS, Rasterman, WCPS is also interfaced. And we have prototype implementations also for Google Earth Engine. So you can basically run anything on the Google Earth Engine as well, using our processing environment. And Central Hub is also in the making. One thing that I'm working on and is basically a successor or thing that we worked after openEO was funded, is openEO platform, a federation of multiple of these backend implementations. So you can also go to that, and it proxies a number of implementations out there. So you can have everything in one place. Yeah, that's it for me. Thank you for listening. I'm in the chat for questions.